So this is our U. Now we use trig sum. So that disappears. That's correct. So U is now tangent of theta, and then we continue using trig sum after using the U sum. This becomes 2 pi, the integral of 1 plus tangent theta raised to the second, and then here we have secant squared theta d theta. Then S becomes 2 pi, the integral of 1 over secant squared, 1 over cosine squared, which is just secant squared. So you get secant theta times secant to the third theta d theta, and we can continue this. Okay, well, so let's go over exam review questions. Exam 2. So it is page 3, question 2. Well, question 2 says, find the integral of square root of 2x minus x squared dx. So we're going to resolve this problem. For this problem, first we have to complete the square. We have 2x minus x squared, which can be written as negative x squared minus 2x, which can be written as negative x squared minus 2x, plus 1 minus 1, which is negative x minus 1 squared minus 1, or 1 minus x minus 1 squared. So this is our integral, the integral of square root of, and you have 1 minus x minus 1 squared dx. So in this case, we're going to use our trig sum. Remember that here you have 1 minus u squared, or a squared minus u squared. So we're going to take, we call that, this is a squared minus u squared, which in this case, u is equal to sine theta. Okay, our u is x minus 1, so x minus 1 sine theta dx is cosine theta d theta. So this integral becomes the integral of square root of 1 minus sine squared, and here you have cosine theta d theta. One minus sine squared is cosine squared, so you get the integral of square root of cosine squared of theta times cosine theta d theta, which is the integral of cosine squared of theta d theta, which can be written as the integral of 1 plus cosine 2 theta divided by 2 d theta, which is theta over 2 theta. theta over 2, and you get plus sine 2 theta over 4 plus constant of integration. So since the original integral is in x, we need to convert theta into x. So what do we have? We know that our sine theta is equal to x minus 1. And then based on this definition and the right triangle, we can find the rest of these missing measurements. So sine theta is x minus 1 divided by 1. So this is x minus 1 divided by 1. So we can find the other one here, which is, let's see, question mark. 1 is equal to x minus 1 squared plus question mark squared. Question mark is going to be square root of 1 minus x minus 1 squared, or 2x minus x squared. So we found all the missing measurements here. We have theta divided by 2. So theta is going to be arc sine of x minus 1. Theta is arc sine of x minus 1. Well, at the same time, you have sine 2 theta. Sine 2 theta is equal to 2 sine theta cosine theta. This is what we learned in pre-calculus. So sine 2 theta can be written as 2 sine theta, which is x minus 1. Cosine theta, the definition of cosine, is square root of 2x minus x squared divided by 1. So we're not going to write down 1 on the denominator. So this integral is equal to theta over 2. Our theta is inverse sine of x minus 1 over 2 plus 2 sine theta cosine theta. So here you have 2x minus 1 times square root of 2x minus x squared divided by 4 plus c. So we can simplify this guy to get 2. Very well. So let's go to page 4. Answer question 1 and question 2. Question 1. Question 1 says, well, find the integral of 3x to the 4 minus 2x cubed plus 20x squared minus 5x plus 34 divided by x minus 1. Okay, we're lucky we already have the denominator written in factor form. X squared plus 4 to the second dx. Well, so note that the power, the degree of the denominator is 5, which is larger than the degree of the numerator. So we need to use partial fractions. So when we're using partial fractions, remember that you have to have your denominators written in the way that you eventually can figure out what the numerator is. There you go. So one of them is in linear term. The other guy is in quadratic term, but it raised to the second power. So we need 3 fractions. This is equal to the integral of the first fraction. The numerator is unknown, x minus 1 plus the second fraction. The numerator is unknown. It's x squared plus 4. And the third fraction, since you have exponent 2, you have to have all the exponents in descending form. So x squared plus 4 to the second power unknown numerator. Well, remember that when the denominator is in linear form, your numerator is just a constant. Let us call it A. Constant A. Here we have a quadratic expression. So its numerator is going to be a linear expression. Bx plus c. Finally, we have another quadratic expression. So it's going to be, let me use a different color. Dx plus b. Okay, the rest is intermediate algebra. Taking the common denominator between these and combining the numerators and solve the system of linear equations. So the rest is intermediate algebra. Okay, so the common denominators between these three is x minus 1 times x squared plus 4 to the second power, of course. So this guy is equal to the integral. Integral of a times x squared plus 4 to the second. Use the same color. A x squared plus 4 to the second plus dx plus c times the common denominator is x minus 1 times x squared plus 4 to the second. So you have to multiply this guy by this and this again to create the exponent c. So we get dx plus c times x minus 1 times x squared plus 4 and plus. So the last fraction doesn't have x minus 1, so we're going to multiply dx plus b by x minus 1. Divided by this common denominator that we know is x minus 1 times x squared plus 4 to the second. Okay. Now your job is to find what is A, what is B, what is C, what is D, what is E. So what we're going to do, we're going to write everything in expanded form and set it equal to this expression, this numerator, our original numerator. So on the left-hand side, you have 3x to the 4th minus 2x cubed plus 20x squared minus 5x plus 34, which must be equal to, here you have a times x to the 4th plus 8x squared plus 16. And okay, let us multiply these. Here you get bx squared minus bx plus cx minus c times x squared plus 4 plus, now you multiply these two, dx squared minus dx plus ex minus e. So again, we have to multiply these two as well. So we get a x to the 4th plus 8a x squared plus 16a plus, well, we get bx to the 4th plus 4bx squared minus bx cubed minus 4bx plus cx cubed plus 4cx minus cx squared minus 4c, and the rest of these terms, well, plus dx squared minus dx plus ax minus e. Now you need to group every term with exponent 4, every term with exponent 3, every term with exponent 2, and exponent 1, and the constants. So let's see. X to the 4th, x to the 4th. Do we have anything else? No. So 3 is equal to A plus B. Left-hand side and right-hand side are equal to each other. Now let us deal with x to the third. Here you have 1x to the third, another x to the third. That's it. Okay. So -2 is equal to -b plus c. Okay, perfect. So now x squared, this guy here, this term here, this term here, and this guy here. The sum of the coefficients must be equal to 20. So 20 is equal to 8a plus 4b minus c plus d. Then now we're dealing with the linear term. For our linear term, we have -5x on the left, and on the right, we have -4b, 4c, -d, and e. -5 is equal to -4b plus 4c minus d plus e. And finally, you have your constant to be worried about. This is 34. And here you have 16a, -4c, and minus e. (16 times a minus 4c minus e). So you have a system of linear equations, and you start solving for these variables. Question 2, we have another integral. It says you have the integral of x plus 1 divided by, what do we have? X squared plus x plus 2 to the second power dx. Well, here we can use a usolve. Here you can convert this and you can complete the square here. Then use usolve to solve it. So here you have x squared plus 2 times a half x plus 1 plus 1. So this guy can be written as x plus, here we got 4. A fourth minus a fourth plus 2. So this guy is x plus a half squared. And here we get plus 7 over 4. So we can complete the square here. And this guy is equal to the integral of x plus a half divided by x plus a half squared plus 7 over 4 to the second dx. And we can separate these two integrals into the integral of x plus a half divided by x plus a half squared plus 7 over 4 to the second dx plus the integral of a half divided by x plus a half squared plus 7 over 4 to the power 2 dx. So now for this part, you can take this quantity inside your parentheses to be u. U is going to be x plus a half with the second power plus 7 over 4, which was our original quantity here. So du is going to be 2 times x plus a half dx. So x plus a half dx is equal to du divided by 2. So this is your du divided by 2 is equal to x plus a half dx. This is du, and this is your u squared. For the second one, we can simplify this by more by taking u to be x plus a half, and du is just dx. So you can write this guy down in front. For this, you can take u to be x plus a half. So du is just dx. So this integral now converts into the integral of du divided by u squared plus 7 over 4 to the second power